Question 1. Which of the following best describes the primary benefit of designing a system with loose coupling? Option A. It ensures all components share the same technology stack and database. Option B. It allows components to be independently developed, deployed, and scaled with minimal impact on others. Option C. It requires all communication between components to be synchronous. Option D. It centralizes all business logic into a single, monolithic application. The correct answer is: it allows components to be independently developed, deployed, and scaled with minimal impact on others. Here's the explanation. Loose coupling means components have minimal dependencies and little knowledge of each other. This enables independent development, deployment, and scaling, increasing agility and resilience, as changes in one component have limited ripple effects. Question 2. In a microservices architecture, an order service needs to notify a shipping service and an inventory service that a new order has been placed, without waiting for an immediate response from either. Which communication mechanism is best suited for achieving this high degree of loose coupling? Option A. Synchronous HTTP REST calls directly to each service. Option B. A shared database that all services write to and read from. Option C. An API gateway acting as a central orchestrator for direct calls. Option D. Publishing an event to a message broker, e.g., message queue or event stream. The correct answer is publishing an event to a message broker, e.g., message queue or event stream. Here's the explanation. Asynchronous communication via a message broker, like a message queue or event stream, allows the order service to publish an event and continue processing without direct knowledge of or dependency on the shipping service or inventory service. They can subscribe and react independently, promoting maximum loose coupling. Question 3. Which AWS service is an excellent example of a deployment model that inherently supports the principles of loose coupling and can be used to implement small, event-driven microservices? Option A. Amazon EC, 2 instances running a monolithic application. Option B. AWS Lambda functions. Option C. Amazon RDS for a shared relational database. Option D. AWS Storage Gateway for hybrid cloud storage. The correct answer is AWS Lambda functions. Here's the explanation. AWS Lambda functions are serverless, inherently loosely coupled, independently scalable, and stateless. They align perfectly with microservice principles, especially for small, event-driven components, allowing developers to focus on code without managing servers. Question 4. What is the primary distinction between recovery time objective, RTO, and recovery point objective, RPO, in disaster recovery planning? Option A. RTO defines the maximum acceptable data loss, while RPO defines the maximum acceptable downtime. Option B. RTO defines the maximum acceptable downtime, while RPO defines the maximum acceptable data loss. Option C. RTO is only for data backups, while RPO is for entire system restoration. Option D. RTO measures the cost of a disaster, while RPO measures the time to prevent a disaster. The correct answer is RTO defines the maximum acceptable downtime, while RPO defines the maximum acceptable data loss. Here's the explanation. RTO, recovery time objective, specifies the target time within which a business process must be restored after a disaster. RPO, recovery point objective, specifies the maximum tolerable period in which data might be lost from an IT service due to a major incident. Question 5. A financial services company requires near-zero downtime and minimal data loss for its mission-critical trading platform. Which disaster recovery strategy would best meet these stringent RTO/RPO requirements, albeit with higher cost? Option A, backup and restore. Option B, pilot light. Option C, warm standby. Option D, hot standby. Active-active or active-passive with full replication. The correct answer is hot standby. Active-active or active-passive with full replication. Here's the explanation. Hot standby, often implemented as active-active or active-passive with fully synchronized environments, provides the lowest RTO and RPO, typically measured in seconds or minutes with near-zero data loss. This comes at the highest cost, due to maintaining a fully operational or fully replicated environment in the DR region. Question 6. Which statement accurately describes the relationship between high availability, HA, and disaster recovery, DR? Option A. HA and DR are synonymous and refer to the same set of strategies. Option B. HA focuses on recovering from regional failures, while DR focuses on preventing service interruptions within a single region. Option C. HA focuses on resilience within a single region/data center, while DR focuses on recovering from catastrophic failures affecting an entire region. Option D. DR is a prerequisite for HA. You must have a DR plan before implementing HA. The correct answer is HA focuses on resilience within a single region/data center, while DR focuses on recovering from catastrophic failures affecting an entire region. Here's the explanation. High availability, HA, aims to prevent service interruptions within a single geographic region or data center. Disaster recovery, DR, focuses on recovering from catastrophic failures that affect an entire region or data center. HA is often a component of a comprehensive DR strategy, providing resilience within both the primary and secondary DR sites. Thanks for watching. Please subscribe to my channel.